So this is 5.2c homework. Number one, they want you to write the polynomial in factored form. So in other words, they just want you to factor it. So the first thing we want to do is make sure that it's in order from the highest exponent down to the lowest exponent, and it is. The next thing you want to do is you want to find any greatest common factor if there is. 3 goes into all three terms, and x goes into all three terms. So if you factor 3x out, you should get 3x squared plus 2x minus 1. At this point, we can factor this out. You can use the box method or you can use trial and error. We're just going to use trial and error here. So 3x times x is going to give you the 3x squared. The only way to get 1 is 1 times 1. We want the sum to be a positive 2x. So when the 3x times the 1 is going to be the one that you want positive. And then the negative 1 times the x you want to be negative. Because 3x times 1 is 3x. Negative 1 times x is negative 1x. When you add a 3x to a negative 1x, you get the positive 2x. And then it's completely factored at this point. You could have also used the box method and gotten the same exact thing. This one, they want you to find the zeros of the function. So the zeros of the function is going to be x equals 0, so that's one of them, minus 2, and negative 3. So negative 2, negative 3, and 0. These three are your zeros. Now, in order to get additional points, what we can do is we can graph this. So it's going to be x times x plus 2 times x plus 3. We're just going to go straight to second table just to get some additional points. It looks like it's going to rise pretty fast. So after 0, 0, we have 1, 12. So we can plot that point here. Aside from that, it's just going to go up really fast up to infinity. We also have the point negative 1 comma negative 2 right here. We have our other two zeros at negative 2 and negative 3. Negative 4 is going to be negative 8, so negative 4 comma negative 8 is going to be right here. And in addition to that, what we can do is find the local max and local min. So I'm going to fix my window back to standard, just so that we get the bottom points and top points. So let's find our local max right over here. So second trace 4. Let's go to the left of that max. Go to the right. So at negative 2.5, we're going to have 0.6. So negative 2.5 comma 0.6 is right around there. We can do the local min also. So second trace 3. Go to the left, to the right of the point. So at negative 0.8, it's going to be negative 0.8 comma negative 2.1. So right around there. So knowing all that, we can graph this as best as we can. Whoop. That's good enough. And there's your graph. Next, write a polynomial in standard form with the given zeros. So, negative 1 comes from x plus 1. Negative 2 comes from x plus 2. Negative 3 comes from x plus 3. Negative 4 comes from x plus 4. What I would do with this in order to multiply all of this out, I would just multiply those two together and then those two together first. These two together is going to be x squared plus 2x plus 1x, so that's going to be plus 3x. And then 1 times 2 is 2. This one's going to be x squared plus 4x plus 3x is going to be plus 7x and then plus 12. Now we want to distribute here. So we're going to have 9 terms. We got to take the first term and distribute it into all 3 here. So x squared times x squared is x to the 4th. X squared times 7x is 7x cubed. X squared times 12 is 12x squared. Then we take this one. 3x times x squared is 3x cubed. 3x times 7x is 21x squared. 3x times 12 is 36x. Then the 2 times x squared is 2x squared. 2 times 7x is 14x. 2 times 12 is 24. So let's add common denominators. Let's start with the 4th degree. So x to the 4th. Then the x cubed. 7x cubed, 3x cubed. That's going to give you 10x cubed. Then the squares. 12x squared, 21x squared, and 2x squared. That's going to be 35, so 35x squared. Then the x's. 36x and 14x. That's going to be 50x. And then plus 24. And then that's your answer. Number 4, find the zeros of the function and the multiplicity. So we'll write the zeros and then the multiplicity. So the zeros, the 0 over here is going to be 1. The 0 here, when you set it equal to 0, you subtract 3 and then divide by 2. So you're going to have negative 3/2. The multiplicity is how many times they show up. Well, the negative 3/2 only shows up once. So that's going to have a multiplicity of 1. This shows up twice because of the exponent here. It's x minus 1 times x minus 1. So this is going to have a multiplicity of 2. All right, number 5, find the relative max and min. So we're going to graph this one. Let's clear that out. So we'll have x to the 3rd minus 7x squared plus 7x plus 15. Graph that. Alright, we see the local min here, but the local max is a little too high. So we're going to have to extend the y max value. So instead of 10, let's make it 25. And see if we can see it now. Alright, so we see the max and min here. So second trace 4, it's to the left here already, so we'll hit enter. Go to the right, hit enter, and then enter again. So the max is 0.57, comma 16.9. So 0.57, comma 16.9 is the relative max. So let's find the relative min now. Second trace 3. So we're going to go to the left of it, enter, then the right of it, enter, and then guess. So 4.1, comma negative 5.05. 4.1, comma negative 5.05. So those are your relative max and mins. This one over here, they want you to find the max, min, and zeros. So let's clear this out. So we're going to have x plus 1 in parentheses raised to the 4th minus 1. Whoops. minus 1. Hit graph. Okay, so we see here that it's going to just kind of flatten out right over here. And it doesn't come back down. So, in order to find the relative max, there is not going to be a relative max because it doesn't top off anywhere. As for the relative min, it looks like it bottoms out right over here. So second trace 3 for the minimum. We're going to go to the left here, and then the right, and then enter. So this looks like it's going to be, this is really close to -1. So let's just say -1. So -1 comma -1 is the relative min. -1, -1 is the relative min. There's no relative max. For the zeros, here and here. So we're going to do second trace 2 to find the 0. So we're going to go left bound is right before it, right bound is just after, and then guess. So -2, 0 is going to be your first 0. And the other 0, second trace 2, that's the just before it, just after it, and then enter again. Whenever you have e to the negative whatever, that means it's 0. So 0, 0 is your other 0, so just 0. And you see that if you were to put 0 in here, you'd get 1 to the 4th, which is 1, and 1 minus 1 is 0. That works. And same with -2. -2 plus 1 is -1. -1 to the 4th is +1. 1 minus 1 is 0. So you know that those are your zeros. Number 7, solve by using any method. Let's use the quadratic formula. So the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So let's simplify it. The opposite of -2 is 2. 2 times 3 on the bottom is 6. -2 squared is 4. Minus 4 times 3 times 4 is 48. So 4 minus 48 is -44. So what we can do is just write 2 plus or minus I root 44 all over 6. That's an acceptable answer. If you used another means of doing it, you probably would have gotten 1 plus or minus I root 11 all over 3. This would also be another acceptable answer, because the square root of 44 can be broken down. And then you can cancel the 2, the 6, and the 2 to get this. But either one of these is correct. Determine the end behavior. Well, the highest exponent that we see is 6. That means it's an even-powered function. And the coefficient of this term that has the degree of 6 is going to be +1, so it's positive. That means the ends are going to both go up. That means the limit as x approaches either positive or negative infinity is going to be positive infinity. Factor the expression. We can use the box method here. So 9x squared and -4. 36 is going to be your AC. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Let's read the signs. Different signs, the larger one's positive. So this one over here we already know is not correct because there is a difference. There's a larger and there's a smaller. 6 and 6 are the same. So the one that adds up to positive 5 is this one. So we have negative 4x and positive 9x. So let's put our signs around and then factor. Nothing common here. Nothing common here. We have a 9x here and a 4 here. So we're going to have 9x minus 4 times x plus 1. And that's your answer. And number 10. Explain how to identify the domain and range of a function from its graph. Well, let's just take a look at a graph of something. So let's say this. How would you identify the domain and range of it? Well, the domain, you want to look at what x values have an output. So on the graph, you want to see how far left and how far right x extends. So how far left and how far right does it go? This goes forever to the left and forever to the right. And it doesn't have any gaps whatsoever in between. So that would mean that this would be all reals for this one. It could start or stop other places. Like, say for this one over here, if you had a graph that looked like this, then the domain wouldn't be all reals. You would see that it extends to the right forever, but it only extends to the left to here. So whatever this value would be, that would be your starting point of your domain. So you want to, in general, you want to look at how far left and right the graph extends, and then check, and then describe that, and then check to see if there's any holes in between. To check for the range, you want to check to see how high and how low the graph extends. So for example, this one over here, it extends in the positive direction forever, but it doesn't extend down forever. It only extends up to this point. So this point over here would be your starting point for your range, and it would go up forever. This one over here, it goes up forever, but it only extends down as low as this point. It doesn't go any further down. So you want to, in general, when you're checking range, to see how high and how low the graph extends and then describe that. Either an interval notation, which is what we're starting to use now, or a set notation, but I'm encouraging interval notation from this point on.